Hello. So this video we're going to talk about how to correct cam timing on a Magnum V10. This is more for those of you who have a reground factory cam and they've had to move the center line to get you where you need to be. So what happened to me, tried for somewhere around 8 months to get a new camcorder. Crower did. They couldn't get one. If you can source one, great. I couldn't source one, so they ended up regrinding. I found one in Florida on a core motor, had it shipped all the way out to California so they could grind it and ship it up to me in North Dakota. I did not want to have my factory cam reground that was in the truck working good just in case something went wrong. And so far, a lot of things have gone wrong. I don't know how much stuff I replaced and or I'm going to use air quotes, fixed, when the issue turned out to be the center line of the cam. So, lesson learned, make sure you degree your cam in. It's very important on these. It was installed on a 118 center line. If you lined it up dot to dot, which, see if you can see that there. The arrow there and the arrow there. The issue with this is they specified a 106 center line. It's a 110 lobe sep with 4 degrees of advance into it. The idea is to build some torque with this because this is a 3/4 ton and I'm sitting here rolling on 35s. And I like to tow with it. So, cam timing. The V10 differs from the V8s right there on that cam gear. It does not have a distributor. If you're this far into this project of yours, you already know that. But if you're just running across this video, V10s don't have a distributor. Front drive oil pump. Amazing similarities to what the LS started to adopt in the Hemis afterwards. I can't say I'm surprised. This motor was kind of ahead of its time, but kind of behind the times too in a weird way. That's a separate topic. But the cam sensor reads off the cam gear. That's what this ring is for. V8s don't have that, so you can't use an adjustable timing set. Well, what do? So this is the factory cam gear, and you can see I got some marks here. Those marks were from when I was trying to center line it. In order to get it on the correct center line, I had to advance it a full tooth. It was within a couple degrees. Called it good. But because the computer sets the fuel sync and it's not adjustable, the fuel sync was off and it still ran like crap. I fired it up as misfiring, kind of like something would load up and then pop. It does have a tune in it for starting it up, running it, making sure everything works good. So it's not a tuning issue. And believe me, almost every sensor on this motor is new at this point. So, brass tacks, how do you correct that? Well, so far, this is the only solution I've been able to come up with, is this right here. This is an offset bushing for a big block Chrysler, big block Chevy, small block Chevy. Now, just happen to have a big block Chevy cam sitting over here. We're going to take a look at this. Look how close that pin is to the center. And if we go over here, this place is kind of a mess. I need to quit doing so many projects. Not only is it a different design, it's a 3-bolt hole, but that pin is a lot farther away from the center. It's overall larger diameter too. Let me grab this here and we'll go over, we'll lay it on top of this V10 gear. So, as you can see, quite a bit smaller. Now, why does that matter? Mathematically, since we're gonna we're using bushings that are labeled in degrees for that bigger gear, the relative ratio between the dowel pin and the center of the gear needs to be the same. Otherwise, the adjustment is more or less. And what I found is, compared to the big block cam gear, the dowel pin on this V10 is relatively closer to the center by a factor of 1.2, which means if you're using a 6-degree bushing like I have in there, that's actually about 7.4, 7.2 degrees. I'd have to go back and look at my sheet. It's a little over 7 degrees on this cam. Now, I've already installed that other gear with the bushing. And one thing I was worried about, and that's why I have the factory gear back on here, is if that bushing can rotate. Because on the GMs with the 3-bolt, it'd be pretty hard for that to slip around. Now, I did put some sleeve retaining compound on it for cylinder sleeves, so that shouldn't be an issue. But I wanted to make sure that even if that did break loose, it wouldn't be able to rotate. Here's why it can't. If you grab this, this is centered on the snout of the cam. Now, since that's centered, it has no side-to-side movement. Okay, it's a little wobbly until you get it torqued down, but there's no side-to-side movement. Why is that important? In order for this to rotate, the distance from the center has to change. So right now this is set at exactly middle point. I put it on there and I pushed that bushing in where the dowel was, because as you can see, that dowel isn't perfectly on the end. All right, and so what I'd advise you do is you put the cam gear up there, put that on, and then I just took either a soft mallet or whatever and just tap it in place gently. I think I actually used a small ball peen and just real gently tapped it in. It is a steel bushing. I did put the sleeve retaining compound on first. I figured it wouldn't be that hard of a thing to knock out of there with a punch if I had to. But since this is centered on there and it can't move side to side, even if this breaks loose, it can't rotate because this distance would have to change, and that distance is set. So that brings me to the last point of this video before I get this all installed. You got to keep in mind that 6 degrees on the cam is 12 degrees on the crank, because it rotates half as much as the crank. That implies that twice as much, because it's the inverse, that's twice as much movement in the crank as it is on the cam. Alright? That means that 6-degree bushing actually changed my center line almost 15 degrees, which follows along with my calculations of about a little over 7, almost 7.5 times 2. So glad to know that was verified. So keep that in mind when you're selecting. In my case, that ended up being about 2 degrees advanced, 3 degrees advanced of what was specified, which is fine. The more advanced you are, the more bottom end you tend to build. If you have one of these V10s, that's probably your goal. You want to get as much torque out of this thing as you can. So that's all I wanted to share. One thing you can note, if you look at the mark from the washer on both of these, that washer will go over top of that bushing enough that it would keep it, if it were to break loose, it couldn't walk out of there at all. It would come up, and this whole edge over here, like right there, would be kept from coming out. And with how tight that fits on the dowel pin, it won't be able to cock at all or anything like that. So you don't really have to worry about that. The reason I point that out is because this cam gear is a little thicker, you can see the lip there, than this one is. Yeah, that's one thing I do have to say about this motor. When Chrysler designed it, everything is just stout. This thing was made to just have the crap beat out of it and to just live. Low compression, good torque, not a lot of power. You can just run it wide open. Unfortunately, I can't leave well enough alone, so I always want more. Just how I ended up in this mess. But I will post a video on whether this worked or not. I'm hoping now in the next couple days to get this thing fired up and just listen to it on startup, see if it seems like it's running good. I have a feeling now with that fuel sync set back to factory. I know it doesn't quite look like it here, but these aren't perfect right now. I'll have to probably line them up a little bit for the final Actually, you know what it is? It's this gear is a little bit different than that other one. That's what it is. When I put that other gear in there, that's how much that bushing was able to change it. Just that slight shift down at the pin. If you look up, so normal installation, that top mark is lined up with that pin. So it's almost a full tooth worth of advance just from that bushing. So that's why it's not lined up perfectly. When I throw that other gear in here, which I'll have to do for final assembly here, that will drop in perfect and all the marks will be lined up. That was just me from earlier from centerlining on that gear. I had a spare gear laying around. That's what I did the bushing on. When I'm doing custom work like this, I always try and retain the factory parts in case something goes wrong, it's not going to work, so that I can at least get it operational again. So anyways, I know this is a long-winded video. There might be, I know there's one or two people who are kind of wondering how this plays out, but when you go to install this, that's what you're going to run into, and that's how that bushing works.